Hello, I'm excited to share my presentation with you today, which focused on the vulnerability chains in the SAP softwares. And today I will demonstrate how to possible to escalate privileges in SAP and jump from on-premises networks to the SAP clouds. Here is the, sorry. Yep. Here's our agenda. And I think it will be help you to understand the flow of our presentation. My name is Vahagan, I'm CTO of Red Race, and Arpine, she's a CEO of Red Race. A few words about Red Race. Red Race is a research and development center in Armenia. We founded 2 years ago. And since 2021, we discovered over 50 zero days in enterprise software, especially SAP, Oracle, etc. So what is SAP? The SAP is a multinational software corporation that specialized in enterprise softwares development, including enterprise resource planning softwares. And ERP softwares is used by businesses of all the size across all industries to manage their today operations. Okay. A short story of the research. Last year, one of our customers requested us to analyze their SAP landscape. The SAP landscape was very hard, but here I wanted to show very simple network structure. The customer gave us an access as a regular user in the user space, and the request was, hey guys, is it possible to find out some vulnerabilities, or is it possible to get information from SAP Cloud from the user environments, user network environments, right? So we started to analyze, and first of all, we built this map. As you can see, we split the map by 3 parts. The first one is a user environment. The second one is on-premises SAP servers environment. And the third one is SAP Cloud environment. The end users didn't have access to the SAP Cloud directly. So they have connection only to the SAP servers on on-premises network, right? But the main components was a Cloud Connector that was connected to the SAP Cloud and was connected to another SAPs in on-premises. So it means that if you would like to compromise the SAP Cloud or get information in SAP Cloud, we should compromise the SAP Cloud Connector, right? But to compromise the SAP Cloud Connector, we should compromise the SAP servers. So we need to jump there, and in the cloud. Okay. When we are compromising the SAP servers, usually we can have 4 types of access. The first access, it can be admin user in SAP application. And the second one, we can get access to the SAP database. The third one is vulnerability or access when we can read we can read files from the SAP application using some directory traversal, just for example, or we can execute some code or command in SAP servers. Okay. Before I will demonstrate vulnerability. I'd like to mention that all the vulnerabilities has been discovered by Red Race during that assessment, only except one, the CVE from 2021. We just reversed it, and all the screenshots that I will demonstrate, I will show you. It's from Red Race demo server. As you I think you can understand that I can't show the screenshots from our customer servers. Okay. So first of all, we scanned the SAP applications, and as our customer was from gas and oil industry, we saw that he used SAP manufacturing execution model. The SAP manufacturing execution model is using in many industries, and the SAP ME model is a Java application that is deploying in Java stacks, application Java stacks. So as the Redress is a partner of SAP, we could download that component, and we started to analyze to discover some vulnerabilities there. We had a low privilege user, and during the research, we found vemo.delio.gsp file in the SAP ME component. And as you can see from this line, the GSP script is receiving file path, some file path parameter, and using file path parameter value, he's reading the file and he's printing that content of the file in the page, right? The payload of the execution is here, and I'm showing this payload here the first time after the fixing. So right now we have access to the SAP application server as, I mean, we can read the files from the SAP application, okay? Then we need to try to escalate our privileges in SAP to get access to another levels. The privilege escalation number 1. The main thing is that SAP stored some critical information in the file system. And on this screenshot, you can see two files, sextor.properties and sextor.key. Sextor.properties file contains, in encrypted mode, application admin password and JDBC connection string with username and password. As we are in the SAP cybersecurity industry over 10 years, we know the encryption algorithm, and of course we have the key of the encryption. And the encryption algorithm is a triple S. We decrypt it, and we got the SAP admin application password here and JDBC connection string. Okay? So right now we have admin user of SAP application, and we could connect to the SAP database. So what's next? We need to, but if you remember the network map, we should compromise the SAP cloud. We try to escalate our privileges again. We escalate privileges by two ways. I will show you here the first way, because the second way still is not fixed by SAP, and I could show it. Here you can we analyzed the other vulnerabilities, and we found NSEC2023 from 2021. And as you can see from the screenshot, for executing this vulnerability, you need to have privilege high, but we already have it. Okay, so if the SAP admins is not updated this component, it means that we can execute this vulnerability also. Again, we download this component, we made a diff, and we found that the SAP fixed the vulnerability in handle save function by uploading some file, and they are checking .gsp in lowercase and .gsp in uppercase file extension. A small tip and trick from me, if you have some Java application and you are trying to upload a .gsp file and the Java application is telling you, hey, you can't upload .gsp, try to upload with uppercases. It can be work. Using that information, of the vulnerable servlet name, function, and others, we built the proof of concept. And again, I'm showing the proof of concept first time after the fixing. And we sent that the following HTTP request to the SAP server, and it works. It works, sorry. Here we can see that we executed the task list command, and right now we can execute the command in the SAP servers. But if you see the screenshot, on the shell script is not displaying the username of soft processes. It means that the user which running our shell script doesn't have enough privileges to show that info, right? So what we need to do? We need to escalate privileges again. After we started to analyze the SAP processes by Process Hacker, and we discovered 3 processes that running under system user. Okay. For us, interesting was the following processes: SAP host exec and SAP OS call exec files processes. Sorry. We used the process monitor for tracking the activities of that processes, and we started to analyze, and we started to tracking what kind of file they're creating, executing, modifying, etc. And we saw that there are a few activities, but the most interesting was that the SAP host exec process, this one, is executing every 2 minutes SAP CIMB.exe process. After analyzing permissions of that file, we found out that any user from the operation system of SAP server could delete that file and write file by this name in the folder. So what we did, we created a shell code in .NET, built and uploaded to the Windows machine. The shell code was should open the port 4444, listen any interface, and when he received the commands, he should execute that command by CMD. Okay, we upload that file and we replace the SAP CIMB.exe file. And it worked. The SAP host exec is executed our shell file. And I don't know why. I don't know what was wrong, but our shell file has been signed by SAP SE. Maybe it comes from SAP, maybe it's a bug in Process Hacker. I need to investigate. But you can see in the screenshot that our shell script has been signed. So after the executing netstat, you can see that port has been open, and we could connect to that shell and execute it with my command. And yeah, we are system. So that's it. But again, you remember that we should compromise the SAP Cloud, right? We need to jump to from one of the SAP servers, here from SAP Java, to Cloud Connector. To do that, we decided to dump memory of LSS process. Our customer said that we couldn't, as we are system, we could disable the Microsoft antivirus and used Mimikatz there, but he said we couldn't disable the antivirus. We couldn't extract the dump to our Windows machine to analyze that dump. So we had another way only. We downloaded the C# mini dump from the GitHub and build that program to dump the process, the dump memory of the LSAS process, right? But of course, this program is detected by antivirus, and by any antivirus, included Microsoft antivirus. So we try to modify that file, the source code of the sharp mini dump. We modified it. We replaced some strings. We replaced strings by chars arise. we compiled again, and we again has been detected by Microsoft Antivirus. And you know, the bypass was so beautiful. We just set some file extension we used file extension that is not has been registered in Windows machine. And we executed by cmd/c mini-dump bypass ms.exe.pp, and it has been executed, and he dumped the password and hashes of the processes. Okay? So after that, we had the admin users and password from application and from operation system. And right now, we should jump to the SAP Cloud Connector, sorry. And you know how we jump? It was so easy, because in the last case, there was over 100 SAP servers, and the SAP admin set the same password for all the SAP servers landscape. So we jumped to the SAP Cloud Connector. We connected to SAP Cloud Connector by SSH and started to analyze the system. As the SAP CC is based on the FH Tomcat, the password was in users.xml file here in hashed mode. So we continue to analyze the system to get other ways how it's possible to discover the password. We found SAP SSFS file. The SSFS, it's a modern SAP secure storage, and which we should try to decrypt this secure storage. After some researching of SSFS structure for SAP CC, we found that the SAP CC SSFS contains the following properties, should contain the following properties. But the encryption algorithm has been written in binary files, and reversing that binary files can take a long time for us, and we choose another way. So that there are lib SAP scc20gni.so file, and that file had one exported function, sexstore access get record. And what we did, we just used that SO library as a native function here. We used that function in our mini Java code, and as argument we passed the properties that we discovered, this one, and we got the password for Java key storage and admin password for the SAP Cloud Connector. So what next? We open the SAP Cloud Connector UI and log in there. And right now, we can manage the SAP connections. We can move the traffic from the cloud to our servers, or we can move traffic from on-premises systems to our another server. And we can manage the traffic, we can listen to the traffic, we can discover some private info, etc. So as a conclusion, the SAP admins should install the SAP security nodes that we discovered, and they shouldn't use the same password for SAP operation systems. They should use different passwords for different systems. I know it can be so hard for the admins, but it's the one way for protecting the SAP servers for password reuse attack. So that's it. Thank you. If you have any questions.